So I'm going to go through the starter questions for this task. So which of the following will not increase the strength of an electromagnet? So an electromagnet depends on the current travelling through it, having an iron core. So you have a current going through a wire, you coil up the wire to reinforce the magnetic field. So coiling the wire will strengthen it. Having a iron core in the middle of it, that will reinforce the magnetic field as well, and having a greater current flowing through it. If you imagine having no current flowing through it, then the strength of the electromagnet will be zero. So which will not increase the strength of it? Reversing the direction of the current. Reversing the direction of the current just changes the poles. So if that's a north pole and that's a south pole, you swap the current round. All that happens is that swaps from north to south, and that swaps from south to north. Next one, definition of half-life. So the half-life of a substance, you've not done this yet. The half-life of a substance, you could look it up. 7 words, time taken for the activity to halve. Now, another way of describing that, time taken for half a substance to disintegrate, that also doesn't quite cover it. So what have we got? Time taken for half a nucleus to decay, time taken for half a substance to disintegrate, time taken for half the nuclei to decay, and then time taken for the nuclei to decay. So time taken for half of the nuclei to decay is the correct answer. UK mains power voltage has a power rating of 350 watts, which fuse is most suitable. So I is P over V, from P equals IV. The power, we're told, is 350, and that's divided by 230. Now, 350 divided by 230 is going to be slightly more than 1, but certainly less than 3. So I can do the calculation and get the exact value, but I can already see the answer is going to be 3. So 350 divided by 230 gives me 1.52 amps. And I'm looking for the lowest value that is greater than the normal operating current. That's that one. Next one, when a ray of light travels from a less dense to a more dense optical medium, the light slows down, and if the light slows down, it will refract towards the normal line. So it's important that we're talking about refraction. So it's going from less dense to more dense. So less dense like air, more dense something like glass. Always use a ruler, and it bends towards the normal line, and that's refraction.